Now suppose we have function f1 which has a 0 of order m1 at z0, a function f2 which has a 0 of order m2 at z0, and so on. And we also have functions h1, h2, and so on, which have poles of order n1. Z0, h2 has a pole of order n2 at z0, and so on. Remember, a pole of order 1 is just a simple pole. A 0 of order 1 is a simple 0. So using our alternative definitions of 0 of order m and a pole of order m, this implies that what happens when we multiply all of these functions together. So if we multiply f1 by f2 by f3 and h1, h2, multiply them all together, then what do we get? Well, 0 of order m implies that we've got z minus z0 to the m1 times some function g. What we know about the g's is that they're all analytic and they're not 0 at z0. So we can just put a big G right at the end with that property. But if we multiply this by f2, then we'll get z minus z0 times m1 plus m2. Okay, so we'll end up with a plus m2 plus all the other m's. And then when we multiply by the h's, then we're going to have things divided by. We'll have z minus z0 to the n1, and then we've got another polar h2 from h2 order n2, so that gives us another n2, and so on like that. And then we have got something we call big G, where big G is analytic, and G of z0 is not allowed to be 0. Okay, so in summary, what have we got? Well, we have a function. Really depends on whether this sum here beats this sum here. If this one is larger than this, then we'll end up with a 0. So then this will have, so if the sum of the m's is greater than the sum of the n's, we'll get a 0 of order sum of the m's minus the sum of the n's. But if it's the other way around, if the sum of the m's is less than the sum of the n's, we'll get a pole of order sum of the n's minus the sum of the m's. And finally, if they're equal, what happens? So if this sum here equals this sum here, then the z minus z0s just cancel out, and there's no longer a 0 anymore. So that, in fact, is just that could be something without a 0. It could be a removable singularity. Basically, there's no 0, there's no pole. This sort of makes it apparent that we can think of zeros and poles as sort of inverse of each other. So we can actually think of a 0 of order m1 as a pole of order minus m1, and vice versa. We can think of a pole of order n1 as a 0 of order minus n1. So yeah, poles and zeros are basically just inverses of each other.